Okay, we're going to start the new unit on area and perimeter. Start with rectangles. Okay. So first definition of a rectangle. We did this with quadrilaterals. Just a review of that definition. So rectangle is a parallelogram, which means the opposite sides are parallel and congruent. It has 4 right angles, and diagonals are equal length. So let's draw a rectangle. So I'll call this rectangle A, B, C, D. We've got 4 right angles, and then diagonals are equal in length. So diagonals AC is equal to BD. That's a rectangle. Now in this unit, we're going to be finding the area, the perimeter, and the length of those diagonals. So area of a rectangle. So if I've got a rectangle, let's call this the length and this the width. They're reversible. It could also be width and length. It doesn't matter. The area of this rectangle is the length times the width. If we have a rectangle, then if this is length, the opposite side is the same, right? These are just opposite. And if this is the width, the opposite side is also the width. And so to find the perimeter of any polygon, we just add up the lengths of all the sides. So our perimeter would be length plus width plus width. But there's a shortcut to that because we have 2 lengths and we have 2 widths. Okay, so you can just add up all 4 sides, or the shortcut, you're twice the length and twice the width added together. So 2L plus 2L. And then finally, the diagonal of a rectangle can be found with Pythagorean theorem. Because we have a right angle, so if we think about the diagonal here, I'm going to call that length D for diagonal. And there's a right angle. Then if this is the length and this is the width, then remember the Pythagorean theorem says a squared plus b squared equals c squared. So the diagonal squared equals length squared plus width squared, which means that the diagonal length is the square root of the length squared plus the width squared.
So diagonal length equals square root plus double.
All right, so take a look at the first example. Let's find the area, perimeter, and the length of the diagonal of this rectangle. Okay, so we've got a length and a width. So the area would be the length, which is square root of 5, times the width, which is square root of 3. Now with the calculator, this is trivial to do. You just put in the calculator. Okay, so bring up the calculator. Now what you have to pay attention to, though, is the square root symbol. So we want the square root of 5. Now if you just do square root of 5 and then square root of 3, notice where the square root goes. It's underneath it, right? So we have to get out of the square root. The way we do that is you do square root of 5, then you press the right arrow. And then times, and then the square root of 3. And you always want to actually look at the screen and make sure it looks like what you have written on your paper. You want to write these down and then put them in the calculator so you can make sure. Because it's really easy to type these in wrong.
3.87.
Okay, so we press enter. And we get 3.87. And we're going to round to 3 decimal places for this lesson. So 3.873. So there's our area. The problem also asks us for the perimeter. So the perimeter is 2 times the length plus 2 times the width. So we have 2 times the square root of 5 plus 2 times the square root of 3. Now I'm putting the length and the width in parentheses because I want to remember that I'm grouping the length and the width. There's 2 lengths. There's 1, 2, and 2 widths. 1, 2. So I've got 2 lengths and 2 widths. And so again, on the calculator, just want to be careful. We got 2 parentheses, and then for square root of 5, you want to make sure you get out of the square root and the parentheses. So press out till you're out of the square root plus 2 times the square root of 3, and then again out. Enter. And you'll notice when you press enter, the parentheses actually go away because they're not really necessary in this particular problem. but it's a good habit to get into the right process to group items, because sometimes your length may be, x plus 3 or something, and so you want to think of that as the quantity x plus 3. So we get 7.936. And then finally, we want the diagonal. So the diagonal is this line right there, and so we have to use the Pythagorean theorem for that. Or we can just use the formula we wrote down on the front, which is the Pythagorean theorem. So the square root of length squared plus width squared. So that would be the square root of 5 squared plus the square root of 3 squared. Now, it's really easy to type this in the calculator wrong, so you want to pay close attention to what you're typing in the calculator. So why it's really important on these practice problems, you're doing it along with me and not just trusting that you can figure it out. So when you're putting the square root in, this time we actually want the square root under the square root. Okay, so the square root of, and then we open parentheses, the square root of 5. Get out of the square root and the parentheses squared. All right, it should look like that. You'll see it kind of, the square root gets taller. Plus, parentheses, square root of 3 out of both squared. And when you press enter, what do you notice? What goes away? The parentheses go away again, and that's also well, mine don't go away. Did your parentheses go away?
No.
No? They did? Okay.
No.
But only on the last one.
Okay, so they didn't go away on that, so that's fine. So we get 2.828. And there's the diagonal line. Okay, so we have an area of 3.873, whatever the units are, they're square units. And we have 7.936 around the figure, and then the length of the diagonal is 2.828. Next example 2 says find the area perimeter and the length of the diagonal of this rectangle. So in this rectangle, we're actually given some angles, 30 and 60. So try to remember back a month or so ago when we were doing right triangles, and we got into special right triangles. We were doing the end of the trigonometry unit. And one of the special right triangles is a 30, 60, 90 triangle. Remember there were two, 45, 45, 90, and 30, 60, 90. So if we have a 30, 60, 90 triangle, so if this is 30, this is 60. Notice which side is shorter. You want to make sure whenever you draw this that you make one of your sides deliberately shorter than the other, which I'm not doing a very good job of. There we go. So there's my short side. So this is 30, this is 60, this is 90. The short side is x. I think we called it A when we did this couple months. So I'm going to call it x. The hypotenuse is twice as long as the short side, and the other leg is square root of 3 times the short side. So almost twice. So in this case, 2x is the hypotenuse equals 2. So what does x equal? So divide both sides by 2, and so x equals 1. So that means that my short leg right here must be 1. And then this longer leg must be 1 times the square root of 3. And so now we have a length and we have a width. So can we find the area?
Yes.
So area will equal length times width. So we have 1 times the square root of 3. Do we really need to put the 1 there?
No.
No, it's not changing anything, but I'm going to. So 1 times the square root of 3 times 1. All right, so it's length times width. And so we put that in the calculator, and we get 1.732. Emma, would you please close the door? Thank you. For our perimeter, we want 2 times the length, so 2 times 1 square root of 3, plus 2 times the width, which is 1, so 2 times 1. And so again, we put that into the calculator.
464.
2 times 1 square root of 3 plus 2 times 1. Oops. And we get 5.464.
Yes.
What's wrong with that calculator? It died like it.
I think it died. It showed the low battery and it started up like twice.
Oh, okay. All right, so we have an area, we have a perimeter. We also want to find the diagonal. So how long is the diagonal of this rectangle?
2.
How do you know it's 2? Yeah, so the diagonal is actually given to us here, so we don't need to put it forward. Example 3. Certain rectangle has a width of 36 while the length of its diagonal is 48. What's its length? Let's draw a rectangle really quick. Just think about this for a second. So we're told it has a width of 36 and a diagonal of 48. And we want to find length. How are we going to do that?
Cube 10.
What are we going to use to do that? But we don't know the area.
You have to find the.
If we know the area, we might be able to use it, but we don't know it. Okay, so we have a right triangle, we have a hypotenuse and a leg, so we're looking for the other leg. Pythagorean theorem. So L squared plus 36 squared equals 48 squared. All right, so A squared plus B squared equals C squared.
Oh, yeah.
So that means that L squared would be 48 squared minus 36 squared. So 48 squared minus 36 squared gives us 1,008. So if L squared equals 1,008, how are we going to find L?
You.
Square root of 1,000.
Take the square root of 1,008. So square root 1,008, and we get 31.749. L squared is 1,008, which means L is the square root of 1,008, which is 31.749. Now, does that answer the question?
No.
Okay, what was the question asking for?
Certain rectangle has a width. What is the length?
What is the question asking us to find? Okay, what is that, the length? Does that answer the question?
No.
Yes, it does. So that's the length, and it's asking for the length. Okay. So definition of a square, remember a square is just a rectangle, but it's a special rectangle with 4 congruent sides and perpendicular diagonals because it's also a rhombus. Okay. So a square is a rectangle that has 4 equal sides. So all the other rules apply. So example 4 says, if a diagonal of a square measures 5, how long are the sides of the square, and what is its area and perimeter? Let's start by drawing a square. And we're told the diagonal is 5. So that would be, this guy right here is 5. Now what do I know about the sides of this square?
That they're all equal.
They're all the same. So I'm just going to call all the sides x. So I don't know them, so I'm just going to use x. So the Pythagorean theorem says that x squared plus x squared needs to equal 5 squared. Because we have a right angle, right triangle, so we can use the Pythagorean theorem. Which means we have 2x squared equals 25. So solving for x, we divide by 2 on both sides, so we get x squared equals 25 divided by 2, which means x would be the square root of 25 divided by 2. Notice this time we actually want the whole 25 divided by 2 in the square root. And so that's what we put in our square root. Square root of 25 divided by 2.
3.53.
And we get 3.536. that answer the question?
No, because we still need to find.
Okay, does that answer any of the questions that were asked?
Yes.
Which one does it answer?
The,
The very first one, right? How long are the sides? So now we know how long the sides are. They're 3.536, whatever's long, right? So area. Area would be length times width, which in this case is x times x. Remember, if you multiply x times x, that's the exact same thing as x squared. That's what x squared means. So what is x squared? X squared is 25 over 2, or 12.5. So the area is 25 over 2, or 12.5, whichever way you want to write. Now the perimeter, because it's a square, it has how many equal sides? They're all equal. So how many is that? 4. So we have 4 x's. Perimeter would just be 4 times the length of the side. And so we have 4 times 3.536. So 14.144. So we have our area, we have our perimeter, we have our side lengths. So notice with a square, the area is just the side length squared. The perimeter is 4 times the side length. But when in doubt, just remember a square is a rectangle, so you can still use length times width, and you can still use 2L plus 2W. Okay, example 5, the length of a rectangle is 6 more than twice its width, while the perimeter is 60 meters. What are the dimensions of the rectangle, and what is its area? Okay, so the length of a rectangle is 6 more than twice its width. We can write L equals, if I want 6 more than twice the width, well, twice the width I could write as 2W, and 6 more than that would be plus 6. All right, so that's 6 more than twice the width. We're also told the perimeter. Now the perimeter we know is 2L plus 2W, and we're told that's equal to 60. So we have a value for L. We can take this value for L and substitute it in for this L. That's what equality means. So we can replace this L with 2W plus 6. So we have 2 times 2W plus 6 plus 2W equals 60. Distribute the 2. So if we have 2 2W's, we have 4 W's. And if we have 2 6's, we have 12. So plus 2W equals 60. Combine like terms, we have 4 W's and 2 W's, so we have 6 W's.
What you added?
Plus 12 equals 60. We're on the same side of the equal sign, so we're combining like terms. We're not moving anything yet. So isolating the W, we subtract 12 from both sides. So 6W equals 48. Divide by 6. 48 divided by 6. W must be 8. And now once we solve for W, we can take that value and plug it in right there. And so we can say that the length is twice the width plus 6, or 6 more than twice the width. So twice the width would be 16. 6 more than that is 22. So the first question says, what are the dimensions of the rectangle? What does it mean by dimensions? The length and the width. So we've done that. We've got our width is 8. And because we're given units, we want to include units in our answer. So the width is not just 8, it's 8 meters. And the length is 22 meters. Then it asks, what is the area? So the area is the length times the width. So it would be 22 times 8. 22 times 8 gives us 176. Now, because it's a meter times a meter, that's like x times x. We get square meters. area of this rectangle is 176 square meters. And finally, example 6 is what is the area of this concave polygon and what is its perimeter? So don't let this word throw you off. Concave, we talked about that a while back. Concave versus convex, like a mirror, concave mirrors, they kind of bend in, right? So concave just means that it's, you have, like this is concave because it's, the corner is inside of the figure. Whereas convex polygons all point out. So we last time deal with convex polygons. For a concave polygon, though, there has to be some other way of doing it. There's no particular formula for a concave polygon. So anybody have an idea how we might find this area? What's something we could do? That'd be to find the perimeter, right? Perimeter is the distance around from at the area. So how much area is inside of it?
Multiply all the way.
We're looking for this area. Like how much paint would it take to cover that area? Yeah, what's up? Okay. 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 So if we think of this as the whole thing, I think that's probably what Leo is getting at too. Am I right? Yeah, that's what you're getting at. Okay. So we think of the whole rectangle and then cut out this area and this area, right? That's what you're saying? Okay. So this whole rectangle, well, this is 5 and this is 4, so we have 4 plus 5. This is 3 and this is 1, so we have 3 plus 1, right? So the area would be 9, because 4 plus 5 is 9, times 4. So that's the whole thing. But then we want to cut out these smaller areas. So we're going to subtract. And this smaller area is 4 by 2, so 4 times 2. And we also want to subtract 1 times 1. So we have 36 minus 8 minus 1. So 36 take away 8 is 28. Take away 1 more is 27.
26.
So our area of this concave polygon would be 27. And then for the perimeter, well, we want to add up all of the sides. So we just want to be sure that we don't include a side twice is basically the idea. And so this time we're actually just going around the figure. We're not including the whole thing. So I'll start with this. So we've got 3 plus 5 plus, and you may consider crossing out the lengths. It's, you know, however, whatever system works for you. 2 plus 4 plus 2 plus, how long is this?
8.
Why is it 8?
Taking away the 1.
Good, so it's 9 minus 1. It's the whole thing, take away that 1, so it's 8 plus 1 plus
26.
so 26. So we get the perimeter, we just add up both sides, we get the area, we have to, and there's more than one way. Another, maybe some of you thought of this, you could also break this, if I erase all of my work here. Another way you might do this is draw some additional lines. And now we have how many rectangles?
3.
Okay, so we can find the area of each of those 3 and add them together. Right, that's a composite figure. There's more than one way to do each of these. Okay, keep that in mind. All right, so that's all of the examples. If you look at the assignment, lines up really well with the examples. So when you get stuck, look back at the examples. They're there for a reason. Okay. I'm not going to call out the answers, but when you finish number 1, if you want me to come by and check your answer, I'll be happy to, and number 2, and so on. The key will be up here. You can also check your own answers. But I'm not going to call them out. I just don't want to.